This is Jack Jackson back with Practice Test 1B Solutions for College Algebra. The calculator is allowed on Part B of each exam and practice test, including the final exam and all the unit exams. Of course, on these practice tests, on the 1A part, you could have your calculator there. I wouldn't know, but you need to be able to do the stuff that's in the A part without a calculator, but the part in the B part can use a calculator. You can use a calculator if you want. So the first question here, fill in the blanks with the names of the standard sets of numbers. Most primitive numbers are the counting numbers. These numbers are called natural numbers. They're the numbers 1, 2, 3, 4, etc. This is the natural numbers, written like this. You throw in 0 with that. Now you have the whole numbers, which is the answer to number 2. You throw in their opposites along with those, and that gets the integers. Okay, and so that's question number 3. And then you go out to fractions, and you have the rational numbers, the numbers that include repeating decimals, terminating decimals. Okay, so the set of numbers of the form P over Q, such that P and Q are integers, but Q is not 0, is a set of rational numbers. Terminating or repeating numbers, decimal numbers, is also another way to say the set of rational numbers. All decimal numbers goes on out to the set of real numbers, so the rational numbers are terminating or repeating decimals, the terminating or repeating decimals. The irrationals then would be non-terminating, non-repeating decimals. Together the rationals and irrationals make up the real numbers. If we go on out to all numbers of the form a plus bi, such that a and b are real numbers where I is the principal square root of -1, that's a set of complex numbers which includes the reals and all of its subsets, along with the pure imaginaries and some other numbers that are complex and neither real nor imaginary. The set of real numbers corresponds to the points in a number line, so that's number 7. The shape of Earth is very close, but not exactly a sphere. That's just a ball like this, set of points that are equidistant from a given point. And you go from the center of Earth out, that's the radius, and they're going to say that radius is 6,371 kilometers. And here are formulas for circumference. That's the distance around the Earth, the greatest distance all the way around, say from North Pole to South Pole and then back up the other side. Circumference is 2 pi times the radius. The area, surface area of a sphere is 4 pi times the radius square, and the volume is 4/3 pi times the radius cubed. So they gave us those formulas, and now we want to just plug in this for r. So let me just show you an easy way to do this on the calculator. Take 6371, store it as r, and now just do the formula as it says. 2 times pi times alpha r. In fact, the times are actually optional. So there is the number. If we want to put it in scientific notation, we move the decimal 1, 2, 3, 4 places. So it's 4.003 times 10 to the 4th power. So the power is 4th power. The surface area of the Earth is by this formula here. 4, I'll just leave out the times this time, it works. Pi r square. There's the surface area. 1, 2, 3, 4, 5, 6, 7, 8. So if we were here at 5.1, then we move 1, 2, 3, 4, 5, 6, 7, 8 to the right. So it's times 10 to the positive 8. So the power is 8. 5.101 is that. And the volume of the Earth is given by the formula 4 divided by 3 times pi times r cubed. that one's already gone into scientific notation. 1.083 times 10, this E12 means times 10 to the 12th. It's already in scientific notation. Let's see here. Rounded to 4 digits would be 4 digits here on the problem, the A part. Next question. Alright, so we have a relation here. What's the domain of range? The range is a set of all first coordinates, -6. We already have -6. 1 and 2. So notice you list those one time. The order you list them shouldn't matter, or doesn't matter. Hopefully it doesn't matter to the calculator or to the to my math lab. It should be -6, 1, and 2 in any order, but you do not list any of them more than once. So don't leave any out. Don't list anything twice when you're listing sets of any kind, including domain and range. The range is a set of outputs or second coordinates, so it's -6, 4, 22. I already have the 4. -6, 4, and 22. That's the domain, and it is a relation because we have ordered pairs. So A is the correct choice there. Notice the problem with D is you've listed things twice, which is not allowed. I think the problem with C is they're backwards, and the problem with B is it really is a relation. They are sets of ordered pairs. So here's a table of X and Y. So -2 is input, 0 is the output. For G, F is given by formula. So F is given by formula, G is given by table. We want to do F of G of 1. So that's F of G of 1. So we start with 1, we apply function G. G means 1 is the input, what's the output for G? Now G is the table, so you find 1 in the input, find its output is -1. So G sends 1 to -1, so the G of 1 is -1. Now we want to do F of that, apply F to that, and see what happens. So -1 becomes the input for F. We want to find the output. The output for F is found by taking -1 and placing it in place of X in the formula. And -1 squared is +1 times 3 is 3. 3 plus 8 is 11. And so ultimately the output starts with, the input is 1 and the output is 11. So 11, our final output, is our final answer. Natural numbers are the most basic counting numbers developed by primitive humans. As mathematics matured and mathematicians matured, it became evident that the number system must be expanded. One of the main reasons for this expansion is to be able to perform the inverse operations of basic operations on natural numbers. What is the inverse operation? Multiplication, division, or multiplying by the reciprocal. In order to perform the inverse multiplication on natural numbers, in other words, to solve missing factor problems, something like, 3 missing factor x equals 7, we have to expand out to the rational numbers. So we have to be able to allow fractions, rational numbers. Even if we started with integers in our problem, we may have rational numbers in our answer. Okay. Similar setup at the beginning. What's the inverse of exponents? Roots. So, if you so the inverse of multiplication was division. So if you multiply, say, by 3, and then you divide by 3, you're back where you started. Similarly, if we raise to an n power and then we take an n root, we're back where we started. And at least if n is an odd number, that works. Okay, and so we want to expand this to operations. What do we have to do? We have to be able to solve missing base problems. So a base to the second power equals 7. We have to be able to take a root, and that means we have to go to, well, that would take us to the real numbers there. But notice if we want negatives here, we also have to have our imaginary number here. So in general, we've got to have all the complex numbers for this. Let A be the event that you earn an A on the first exam in this course. Let B the event that you're taking the course in a full online environment. What best describes A, and that's pronounced intersection B? So A intersection B is the overlap of the two. In a Venn diagram, it would look something like this. You're looking at A intersect B is the intersection of A and B is the overlap. So it has to be both. So something's in, an event is in that, if and only if it's in A and it's in B. So intersection corresponds to and. Intersection of sets and between logical expressions. So that's C there. You're taking the course in a full online environment and you earn an A on the first exam. If it was or, it would be the union, including the possibility of both. Well, there we go. That's the next question. Same thing. A union B. A union B is if it's in A or it's in B, including the overlap. So that's A union B. Something's in that if and only if it's in A or it's in B. So or and union correspond to each other. And notice this does include that overlap. So the correct one would be C. You are taking the course in a full online environment, or you earn an A on the first exam in this course, including the possibility that you do both. So an or union is an inclusive or. Alright, so here we have some model. P of Q is negative 0.0044 Q squared plus 4.41 Q minus 130. Okay, regardless of know what this looks like, if we know what it looks like ahead of time or not, we can put this in our calculator. Of course, we're going to do it slightly differently. We're going to change to X's and Y's. Specifically, we're going to change to Y1 for P, and for Q, we're going to use an X. We should use a negative here, not a subtract. 0.0044 X squared plus 4.41 X minus 130. Now, what would be an appropriate window for this? We've got to experiment maybe a little bit with our window. Well, Q is a quantity of items, so that's has to be positive, or 0, never negative. So we've got to start X at 0. I really don't know how many items we want to go out at. Down here it says 100. Maybe we're going to go past that for sure. So let's go 200 items. If we do that, let's mark it off in tens. Now we could have a negative profit. That means we lost money. And notice when Q is 0, we do start at negative 130, and we hope it's going to go up from there. So our Y min needs to be about negative 130. Let me make it negative 150. And I don't know how high we need to go, but how about 1,000? Maybe mark it off in hundreds. Alright, let's take a look at the graph and see if that is... Okay, it looks like we might be getting up close to maximum here. Maybe I went up too high, but I also didn't go out far enough to the right probably. So let's change that a little bit. So let's go to 400. Maybe mark it off in 50s. And, oh, I went to 10,000. I went to go to just 1,000. So maybe 1,000 would be okay. Alright, we're getting really close. We maybe need to go a little further out to the right. So let's go out another couple hundred, maybe 600. Alright, that's pretty good. We can see the maximum, which is the maximum profit you're going to make. The X here will be the number of items to make the maximum profit. The Y will be the actual maximum profit. The break-even points where it crosses the axis, the x-axis, and the initial 0, negative 130 says our fixed costs are 130. So if it makes 100 items, we're told an X and we need to find a Y. On your calculator, the easy way to do that is just hit trace, type in the X, and it will tell you the Y there, and it'll find the point for you. There it is. And the Y is 267. Y's are dollars here, profit. X is number of items made. Y is P, profit, in dollars. X is Q, quantity and number of items. So if they make 100 items, they make $267 profit. Find the break-even point. That's where the profit is 0. So we're looking for this place where it crosses the axis. To find that, we go second trace, which is calculate. We want to calculate a 0. So I can type in 0 for the left bound. Use my arrow key to go to the right bound. Notice the y's are negative. Alright, now we got y's positive, so that's good. Hit for the right bound, it's somewhere in between. Get my cursor close to the axis there. And it figures it out. 30.4, etc. items and 0 profit. So it says round to the 10th of an item. That's 30.4 items. So this problem is intended to be done completely with the calculator. Later on in the course we might learn how to do this without a graphing calculator, but right now this is intended to be done with a graphing calculator. Now we want to find the maximum profit. So that's second trace again. For calculate, this time we're calculating the maximum number 4. So type 4. And it asks you for a left bound, so we're way over here. We want to go over closer to it, to that maximum, but we still want to be sure that we're on the left side. Well, that's good enough. And then we want to go on the right side, so we want to make sure we go past that top and go to the right side of this. And so we're looking for the maximum value in this interval. Alright, that's good. Hit enter. And then for a guess, you want to try to put it there. Put that y as about as big as you can get right there on the top. Hit enter, and it'll zoom in there, and well, it won't zoom the graph in, but it'll use an approximation technique to find that point. And so this is the number of items. This is the profit. So that profit is about $975.01. Hundredth of a dollar, 1 to the cent, and the number of items to the 10th of item is 501.1. So that shows you how to use the calculator to find a maximum. A minimum would be calculated very similarly. We also were able to find a 0, which is an x-intercept. And let me do one more kind of problem here, just while we're at the calculator. If I wanted to find how many items to reach a particular profit, like say $800. Now I know the y and I want to find x. I can graph a horizontal line and I can calculate this point of intersection. Technically there's another one over here, but the company's not going to go that far. They're going to, once they start seeing the profits dropping, they'll stop making items. So we want to find that guy here. We can go calc, which is second trace, and this one we want to find the intersection, number 5. First curve is identified as y1, enter. Second curve is y2, that's good, enter. Guess, enter. And you can see that it's about 301.7 items. So that's how you can take a y and find an x. They didn't ask that on that question, but that's a common thing that we might want to do. Alright, here we have a Venn diagram. I actually drew this for you a little bit earlier on. The one in the middle is the simplest numbers, the natural numbers, so that's F is the natural numbers. Next out from that, including the natural numbers and the number 0, is the whole numbers, E. Throw in their opposites, now we're at D, that's the integers. Go out bigger than that. C is going to include the integers, would be the rational numbers, C. And then including the rational numbers would be the real numbers, B. And the one that includes all of them, A, is the complex numbers. And I drew that diagram for you earlier in the going over this video. Alright, so here we have another real-world application problem. Sound exerts a pressure P on the human ear. The pressure increases as the loudness of the sound increases. If D is the loudness of the sound measured in decibels and P is the pressure of the ear, it should say, in dynes per square centimeter, the relationship is given by this formula. P of D equals 0.002 times 1.122 to the D. Okay? So compute P of 65, then just plug in a 65 here, and we're going to use our calculator to get an approximation to that. So 0.002 2 times 1.122 to the power 65, and that turns out to be about 3.55, rounded to 2 decimal places, so 3.55. So P equals 3.55 when D equals 65, or 65 comma 3.55 is our ordered pair DP. So 65 is the decibels and 3.55 is the pressure. So the pressure on the ear in dynes per square centimeter when the sound is 65 decibels is what the 3.55 means. A. C is backwards. Consider relation is the algebra teacher of. What could be a possible domain? Well, it's got to be the algebra teachers, so could be all instructors teaching algebra at UAFS this semester. That would be reasonable. Wouldn't be the students. Wouldn't be all faculty members because they don't all teach algebra, so it'd have to be A there. Which could be a possible range? Well, it'd be all the students taking algebra at UAFS this semester. So if the domain is all the algebra teachers at UAFS this semester, the set of all their students would be the range. So if Jerry, Jack is an ordered pair of this relation, which of the following is true? Jack is the algebra teacher of Jerry. So you place this statement between the two things and read them in order. Jerry is the algebra teacher of Jack. So blank is the algebra teacher of blank. First blank is first coordinate, second blank, second coordinate. So Jerry's the algebra teacher, Jack is the student. Does this define a function? No, it's not a function. What does it take to be it is a relation because it generates sets of ordered pairs. Is it a function? Well, no, because a function has to have no repeats in the first coordinate. And, for example, I'm used as an algebra teacher for many of you. So I'm used as a first coordinate multiple times. So even if I'm used twice as a first coordinate, it's not a function. And so certainly if it's not a function, it's not a one-to-one function. Choose the correct graph. Okay, well, a couple of ways we could do this, but the easy way, if we've got our calculator, is just to plug it in the calculator and see what happens. X squared minus 7, we don't necessarily now need to know what this looks like in the beginning. Notice this goes negative 10 to 10 on both X and Y. That's a zoom standard. So if I just do zoom 6, that will set our window up. If you notice, that sets the window up from negative 10 to 10 on both X and Y. And that's what the graph should look like, and the one that looks like that is A. If I really got down to it and needed to, if the two of them are really close, then of course I could look at my table here and maybe do a table setup and start at negative 10 and go up by ones, and then look at my table and make sure that these points, the ones that fit in the window, are the right ones. But in this case, I didn't really need to do that. In 2005, it took 19.79 currency units to equal the value of one currency unit in 1913. In 1990, it took only 12.60 currency units to equal the value of one currency unit in 1913. So basically what you're looking at here is inflation, and we're saying when it says the value, so let's take something that existed in both years, like a loaf of bread and or a gallon of milk. So whatever money it took to, however much money it took, let's say if you took $19.79 of milk in 2005, that would be equal to about $1 of milk in 1913. So you kind of see what that means there. Not necessarily just for milk, but in aggregate, what the prices have done. So basically, if you look at this, if you've got basically you've got the old and the new, So you've got y is the 2009, or y is the units, equivalent units, and in year X is the year. Okay? Can we look at some ordered pairs here? So what we're saying is we've got X's and Y's here. When X is 1913, Y is 1. And when X is 2005, Y is 19.79. Okay, so there's some kind of function that comes here. Well, they give us the function, so that's nice. They didn't ask us to figure it out. They just flat out told us. And X is actually the number of years since 1913. So this is actually 0. And 2005 minus 1913. Oh, of course I can do that without a calculator, but that's 92. So these are the actual X's. These are the years. But here are X's and Y's. I mean, you could check that out to be sure it works. So again, if I've given a formula, one of the first things I'll probably do is just type it in. Okay, and maybe this needs to go from 0, which is 1913, up to, well, it's 100 years past that now, so how about 100 years? Okay, might as well start at 0 and go up to, well, don't know, 30. Mark it off every 2. Okay, we've got a lot of dead space here. We can either come in on the X's or go up on the Y's. Let me go up on the Y's. Let's go up to 100 there. And if we're going to go 0 to 100, we probably should mark it off in like tens for the X and the Y. This may give us a decent looking graph. Yeah, that's decent. So there's a graph of it. In 2009, how much will it take? Well, we need to figure out what the X value is. So 2009 minus 1913 gives us an X value of 96. And if we look at our graph, we can just hit trace and type in that X value, which was 96, right? And that gives us the Y. Hang on a minute, was I in the right place here? 2009, okay. I didn't get the answer they have. Do I have something typed in wrong? 13 point. Okay, that looks right. So trace 96, 60.1. Something doesn't look right here. Let's put in 0. Oh, wait a minute. X is the year. X is something. Oh, X is since 1990. Okay, alright. Start over again. These are the wrong X's here. So if you put in 0, it should be how much it is in 1990. Okay, start over again. Actually, the formula is still in there right, but it's 2009 minus 1990 would be 19. Let me change my window just a little bit. Let's go from negative 100 to 100. Okay, so down here where it was 1 year would be 1919. I didn't have to go that far to the left. But anyway, let's look at this. And so anyway, I want to figure out the right year here. Get it right here. 19. So now if I do a trace and type in 19, 22.56 currency units. So $22.56 in 1996 would be the same as like $1 in 1913. How about in 2018? Okay, so let's figure that. 2018 minus 1990 is the X value, which is 28. So I can do trace 28 and do that. So what am I really doing? When I say trace 28, I'm putting 28 in place of this X and figuring out what this is. 26.96. So notice that's the same thing as if I said 0.4884 times 28 plus 13.2812. Same thing. Okay, when will you get approximately 30 currency units? In other words, now they've told us that this is 30 for the value or for the Y. So we have to solve this equation, which we can certainly do. If you did it by hand, you'd take the 30, you'd subtract 13.2812, get an answer there, and then divide that answer by 0.4884. But there's also, so it's 34 point something, okay, 34 years after 1990. Of course, plus 1990, the year would then be 2024. Okay, now, we can get the same thing, though, by going to here. If we know a Y and we want to find an X on our calculator, we can plug in the Y of 30 for Y2. That's going to graph a horizontal line, and we just need the intersection point of these two lines, which you can do by calc, second trace, calc number 5, calculate the intersection, first curve, enter, second curve, enter, that's good. Use your up or down arrows to move among the curves and select the right ones if you have more than two graphed. If you just got two graphed, it's easy, it's enter, enter. And then put your guess close to where they cross and hit enter. And sure enough, when you quit there and type that X, it's the same one that we got up here the other way. Next question. Another real-world application, the elevation E in meters above sea level at which the boiling point of a certain liquid T degrees Celsius is given by the function below. So the elevation is 1,100 minus T plus 560, 100 minus T quantity squared. In this case, we're giving the elevation for different boiling points. And so the boiling points are the T's. So we just plug in those T's. We can do this a couple of different ways. Here's one way we could do it on the calculator. We could take the 99.5, store it as T, and just type in the formula now as it looks. 1,000 parentheses 100 minus T, alpha T, plus 560 parentheses 100 minus alpha T, close parentheses, squared. And it will use that 99.5 in place of T and get 640. Now the cool way about doing this is I can do the next problem without as much typing because I can take 100 and store it as T. Now I can go second enter, which brings up my last thing. Now, but without hitting enter, go second enter. That brings up the one before it. That's the one we want to do, but now it's going to do it with the new value of T, and that is 0. So 100 degrees Celsius is the boiling point at sea level. But as you go higher, the boiling point is going to go, you can see the boiling point is going to go down a little bit. Boils a little bit lower temperature. because there's less air pressure. Alright, now we got a little bit of just some manipulation here of some expressions with some exponents. Okay, so 48, I'm going to break these down to prime numbers. 48 is 4 times 12, which is 2 squared times 4 times 3. It's another 2 squared and a 3. So a total of 2 to the 4th times 3. The x to the 19th is going to go to the bottom when it becomes a positive power. The y to the 14th is going to stay where it is. The x squared stays where it is. The y to the 7th goes to the top because it was a negative power. The 52 I'm going to break down to prime numbers. I think I can divide a 4 out of that as well. 4 times 13. So that's 2 squared times 13. By breaking them down to prime numbers, we can treat the x's and the y's and the 2's and 3's and 13's just the same way. So these cancel out, leave me 2 2's in the top, 2 squared. The 3 doesn't cancel, the 13 doesn't cancel. The x's are multiplied together, so we add the exponents, so that's x to the 21. Similarly, the y's are multiplied, so we're adding the exponents. That's also 21. Don't leave it like this in the top. 2 squared is 4 times 3 is 12. So it's 12 y to the 21st over 13 x to the 21st. We will leave it like that, which is what they have. Be sure you use your little fraction button over here on the left to get that, and your little superscript button here to get the exponents. Alright, another one where we're dealing with exponents here. Negative 3, x to the negative 16, y to the 17th to the negative 3. I usually just work inside the parentheses first. So I'm going to make that these stay where they are, but that negative exponent flips that down to the denominator, becoming a positive exponent. When I make the exponent on the outside positive, everything inside the fraction there flips. Now we raise each part to the 3rd power because it's all multiplication. And we get, now we multiply the powers here. 16 times 3 is 48. Negative 3 times negative 3 times negative 3 is negative 27. Usually we write the negative out front here in the end. And then we multiply the powers here. 42, no. Yeah, 42. I miscopied. That's a 17, not a 14. 3 times 17 is 51. Okay, 51. There we go. Alright, so there's our final answer there, which is what they have here. Convert to scientific notation. You put the decimal right here between the 3 and the 4, so it's 3.4. Then you move the decimal. How many places would the decimal be moved to get back to here, where it's 3, 6, 9, 10, so it's 10 to the right, so it's 3.4 times 10 to the 10th. So if we took this, and we'll move the decimal 10 places to the right, we would be back to this. Alright, so we can actually just do this on the calculator. 1.9, actually you can just type it in, times 10 to the power 12. And then divide by 8.1 times 10 to the power negative 13. Notice I've got parentheses around the numerator and around the denominator. And that's already in scientific notation. That's 2.34, etc. That E24 means times 10 to the 24th, which we write this way, not the calculator way, but the way it's written here. And it says round off to thousandths. So it's tenths, hundredths, thousandths. That's 3 decimal places on this part right here. So 2.34, and then that 5 rounds up to a 6 because of the 6 here. A 17.1 mile long bridge tunnel costs $213 million. Find the average cost per mile. So we need cost per mile. So we need to divide dollars by miles. And that'll be the units. The units will be dollars per mile. So we have 213 million, millions, and we're dividing by 17.1 miles. Okay, so we can do that on the calculator. 213,000,000, that's million. 213 million divided by 17.1 miles. This will be dollars per mile. So 1,245,6,140.35 dollars per mile, or approximately, well, notice that this was 3 digits, so they should probably round this off to 3 digits here. 1.25, and then count the decimal places. 3, 6, 8. So this times 10 to the 7. Just 1 past that comma. 7th. And again, that should be dollars per mile. I really should say dollars per mile, but they got the per mile over here, so that's okay. Alright, just a few more here. Simplified expression. We can do this in the calculator. Just be careful that you put parentheses around the whole numerator. 6 parentheses 2 minus 8 close parentheses to the power 5 minus 4 times 6 plus 7 times 4 close parentheses divide by open parentheses 7 square plus 2 cube close parentheses. Boom. It should figure that out for us and round it off the nearest thousandths. Negative 818.456. Same as they have. Big thing there was to remember to put the parentheses around the numerator and denominator. Okay, so we've got miles per hour, and we've got miles. We want to make hours, so what do we have to do? We have to take the miles, and we need to divide by the miles per hour, which will eventually be the same as miles times hours per mile. Or just think of it this way. We start with 92,900,000 miles, and we multiply by 1 hour, it will go 2,900 miles. And if we do it that way, the miles cancel and we get hours. Okay, I'll just use the calculator. Let's see here. 92,900,000 should be a total of 5 zeros. Okay, and then we're multiplying by 1, but then we're just, which you don't have to do on the calculator, but we just divide by 2,900. And that's 32, that's a 2, 32,034.48276 hours, or about 32,000, which would be about 3.2, and then count 1, 2, 3, 4, so it's times 10 to the 4th hours. Okay, so we have 4x minus 5y equals 20. We need to do some ordered pairs here. Well, this one, when x is 0, is a y-intercept, and the one where y is 0 is the x-intercept, meaning it's on the x-axis here and the y-axis on the one up here. So to get the first one, we put 0 in place of x and just solve this equation for y. Of course, 0 times 4 is 0. 0 plus negative 5y is negative 5y, and that's going to equal 20, and we divide both sides by negative 5 to get y is negative 4. Okay, that's the first one, and that's going to be here on the x-axis, or the y-axis, 0, negative 4. Now to do the other one, we're going to put 0 for y. Again, 0 times anything is 0. When we add 4x, of course, we get 4x. That's supposed to be equal to 20, so just divide both sides by 4, and we get x is 5. So 5, 0 is right here on the x-axis. Be sure you pay attention to the scale. Probably want to look at a bigger graph. Now, what it didn't say was this was a straight line. Okay, now, if you know something about linear equations, you might have known from your earlier classes that this is a graph of a straight line. And so you know to choose the graphing tool that's a straight line on the right and do it. But if not, what could you do? Well, if you didn't know that ahead of time, you could plot several more points on a piece of paper, figure out that they are all in a straight line, and then use the straight line tool. Or, remember we got our calculator, right? So let's go back to our calculator. We've got 4x minus 5y equals 20. Now, to put this in the calculator, it needs to be y equals. So we need to solve for y by subtracting 4x from both sides. And then divide both sides by -5. So I could actually leave it like this, or I'm going to distribute and write it as 4/5 x minus 4. So I'm going to put that in my calculator. 4/5 times x minus 4. y1, y2, it doesn't really matter. Well, let's start with the zoom standard. Okay, so that's what the graph should look like. In fact, a zoom standard is good because it's -10 to 10, which is what this is. Also, we see it's a straight line, so we choose the straight line tool, specify those 2 points, we're good to go. How can we also find those 2 points? Trace 0 will tell us the one on the y-axis, 0, -4, and we can do a calc 0 to find the one on the other axis. This is easier to do by hand, honestly, in this case, but we can do it here. Left, right, guess. And of course that should be 5, 0, and it is. Okay, so we can graph this next one. The opposite of x squared plus 1. Notice, by the way, this means you square first, then take the opposite. So, for example, if I were to put in 2, I would square the 2 first to get 4, then take its opposite, which would be -4 plus 1 is -3. So the order of operations is, we need to understand that, but we don't need the parentheses. The calculator will figure this out, and we just need to set up a table here. If we started at -3 and go up by 1s, automatically, now when I see my table, it will give me this part of the table we need, -8, -3, and 0 for the things. And then if this is a standard window, so if I do a zoom standard, that goes from -10 to 10. Which one of these looks like it? Well, that's D. And I believe we've come to the end of our questions, so that will hopefully give you some nice things to review for practice test 1B. And now you can go back, and if you need to, retake that practice test or use this to help you study for the exam, which will be somewhat similar to this, probably quite a bit shorter, but the same kinds of questions. So we should be able to be comfortable with working with our calculator and without our calculator on these concepts.